this, the next thing we need to check is the circuitry of the ECU's power supply. First, we check the EFI main relay. Remove the relay. And measure the resistance between terminals 1 and 2 to see if the coil is intact. If this is okay, connect the battery to terminals 1 and 2 and measure the resistance between terminals 3 and 4 to see if the contacts have closed. If no problems are found, the EFI main relay can be reinstalled. Now, measure the voltage between terminals plus B or plus B1 and terminal E1 of the ECU. If the measured voltage is equal to the battery voltage, there may be a problem in the grounding of terminal W of the ECU. If the battery voltage is not being applied to terminals plus B and plus B1 of the ECU, there may be a problem in one or more of these areas. In some cases, the check engine warning lamp will not go off even after the engine has started. Normally, when the engine is started, NE signals from the distributor are input into the ECU, causing the transistor to turn off. This, in turn, stops the current from flowing to the warning lamp, so the check engine warning lamp goes off. But if the diagnostic function detects a malfunction in a signal system, the check engine lamp will light up even while the engine is running to warn the driver. For this reason, if the check engine lamp lights up while the engine is operating, first short the T and E1 terminals of the check connector like this. And see whether a diagnostic code is displayed. If the check engine lamp lights up but no diagnostic code is displayed, it may be because the wire harness is grounded somewhere between the check engine lamp and terminal W of the ECU. Or it may be that the transistor is not going off as it should. In other cases, a diagnostic code may not be indicated at all when T terminal is shorted. This sometimes happens when there is an open in the wire harness for terminal T or E1. Finally, we need to check the backup power supply of the diagnostic system's memory. This memory allows the ECU to store trouble codes even when the ignition switch is turned off. The check should be done by measuring the voltage between terminal BATT of the ECU and the body ground. If no voltage can be found, we should check the fuse. Our next subject is inspection of the fuel system. Fuel system inspection begins with the fuel pressure check, as this determines whether the fuel system as a whole is functioning normally or not. In this volume, we will talk about problems in the system that cannot be detected by the diagnostic function. So, let's see how this check is made. First, of course, we check to see if the fuel tank is full. Then, we install a fuel pressure gauge in accordance with instructions in the repair manual. There are 4 items that should be checked using the pressure gauge. First, we check the fuel pressure while the engine is cranking. The normal range is shown on the gauge in green. Then, we check the pressure when the engine is idling. Now, we check the pressure when we suddenly open the throttle valve all the way. Finally, we stop the engine, wait for at least 5 minutes, and measure the residual fuel pressure. If the pressure gauge reading is within the normal range during all 4 of these pressure checks, you can conclude that the fuel system is in good condition. If a reading differs from normal values, we must check further. But before we do this, let's see how the electrical circuitry of the fuel pump operates. When the engine cranks, electric current flows from terminal ST of the ignition switch to coil L2 of the circuit opening relay and then to ground. Therefore, the relay turns on. At the same time, current flows to the coil of the EFI main relay, causing the relay to turn on and current to flow to the fuel pump via the circuit opening relay. The fuel pump, therefore, begins operating.
فراموش نکنید که توی کانال سابسکرایب کنید و کانال رو با دیگر دوستانتون به اشتراک بذارید. تا ویدیوی بعدی، روزگار خوش.